Chapter 9 Review. Question number 1. You are asked to identify the following four equations, whether it's a circle, an ellipse, a hyperbola, or a parabola. So let's go over the information we discussed in Conic section for the last month. Which one would define a circle? A circle, you need both of the x squared, y squared term. So both of your variable would have to be raised to the second power. It's a conic section, they both have to be raised to second power. Next, take a look at the coefficient. So the coefficient for the quadratic term, 1 times 1 times. This gives us the ratio of the quadratic term coefficient, 1 to 1. This is what I mean by coefficient ratio of 1 to 1. Only when you have this kind of relationship will tell you this is going to be a circle. So D would represent a circle equation. Which one would represent an ellipse? Ellipse, remember, both of your x and y would have to be raised to a second power as well. But look at the coefficient of the quadratic terms. Do they have a ratio of 1 to 1? In this case, we have the ratio of 1 to 4. So it is no longer a ratio of 1 to 1, but you have the x squared, y squared term. So for letter C, it's going to describe an ellipse equation. Which one is going to tell us it's going to be a hyperbola? So personally, I think hyperbola would be the easiest. Why is it? Because you will have the quadratic term x squared, y squared, and the ratios. So the coefficient is differ in size. So if you have the quadratic term x squared, y squared, but the sign is different, so one is positive, the other is negative, you can quickly identify this to be a hyperbola. So was that easy? And the last one, it's going to be a parabola. But why? Even though you know using the elimination process, you know letter B is going to define a parabola. But why is it? It's only because you see there's only the y squared. One variable is being raised to second power. So you only have one variable squared. So that defines a parabola. Question number 2. We're going to copy the circle equation from the previous one, x squared plus y squared minus 8x minus 2y plus 6 equals 0. The reason why it's a circle, so let me repeat the information again. Both of your x and y are squared. The coefficient of the quadratic term have a ratio of 1 to 1. So don't forget this. This is pretty critical. Next, you are asked to convert the circle equation into standard form. So when it comes to circle form, standard form, we're going to do the completing square. So once again, how do I complete the square? First thing, make sure your leading coefficient terms are with the leading coefficient of 1. Next, takes your linear term coefficient, divide that number, no matter what that number is, divide it by 2, then square it. Take that linear term coefficient, divide it by 2, then square it. And because we are balancing across the equal sign, whatever you add to one side, make sure you add it to the other side. That's the balance you have to maintain across the equal sign at all time. So next step, figuring out the numbers we add. So I am going to repeat this equation again, x squared minus 8x, negative 8 divided by 2, that's negative 4, negative 4 squared is 16. Negative 2 divided by 2, that's negative 1 squared is 1. So on the both sides, you can see I am adding 16, I am adding 1. So basically, I did not change the equation at all. So now, can I put these three terms into a perfect square form? can I put these three into perfect square form? Have to be careful there. It's y minus 1 squared. What's negative 6 plus 16 plus 1? So now is this format in the standard form? If you want, you can rewrite it into x minus 4 squared plus y minus 1 squared equals the square root of 11 squared. From here, we can identify the information of the center. The center is going to be located at 4, positive 1, and the radius is going to be square root of 11. Don't forget to take the square root of your constant. What does your graph look like when you graph the circle equation onto the graphing paper? For question number 2, you will find the center location is going to be located at 4, 1 with a radius of square root of 11. Square root of 11 is about 3.2 something. So from this center location, you can see it's square root of 11. From this center location, square root of 11. From this center location, square root of 11. From this center location, square root of 11. Question number 3. The parabola information we have from question number 1 is letter B, y squared plus 6y plus 8x plus 25 equals 0. Why do I know it? It is a parabola. So because only the y is squared. So only one variable is squared. So this is the reason, main reason why I know it's of the conic sections that it's a parabola. Next, we're asked to rewrite the equations into standard form. So once again, completing the square. So I've already taken the y squared plus 6y, move it to the left hand side, and move the rest to the other side, minus 8x minus 25. So how do I complete the square? So again, since my y, the leading coefficient is 1, so all I have to do is take the linear term divided by 2, then square it. And because we're balancing it across the equal sign, so what should I do? Should I add or should I subtract? So of course I add a number, I have to add the numbers to the other side as well. So let me quickly put these numbers, equations in order so that it's easier to read. So I have y squared plus 6y plus 9 equals negative 8x minus 25 plus 9. So you can see now, plus 9, I am not changing the given equation. So with these three terms, can I make it into a perfect square term? Y plus 3 squared equals negative 25 plus 9, so that's negative 16. And what's the common factor between negative 8 and negative 16? Can I factor out negative 8? So then I can rewrite the function into y plus 3 squared equals negative 8 times x plus 2. So from here, can you identify the P, the vertex, the focus information? So remember, we have the information we discussed. 4P equals negative 8. That makes our P divide both sides by 4 equals negative 2. Meaning that we would have an opening left because this is a y squared. Opening left, P is a negative 2, a negative number, where the vertex is going to be located at negative 2, so this term, negative 2, and negative 3. Where's going to be our focus? So it's an opening left, it's going to change our x values. So we have negative 2 minus 2. Focus is always inside the parabola, which gives us the focus is located at negative 4, negative 3. The directrix, so negative 2, you will have a vertical directrix. So x negative 2 minus negative 2 equals 0. x equals 0, that means our y-axis is going to be the directrix. Question number 3, parabola. What does the graph look like? So the parabola would have an opening left, and the vertex I mark it down for -2, -3. Remember our P 2 units. So from this vertex location, I subtract 2 units, and then from the vertex point, I add 2 units to find my directrix. So the red one happens to be our y-axis, representing the directrix. And the lattice rectum, remember the special case, lattice rectum is 4 times P, so it has a unit measurement of 8 units. Question number 4. Looking for the ellipse equations. So using the information from question number 1, I have x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. Why do I know it's an ellipse? Because both of your x and y are squared. So both of the variables are squared. The leading coefficients ratios is not 1 to 1. So again, the critical part is both of them, x and y, are squared. The leading coefficient ratio is not a 1 to 1. Next, rewriting into standard form. So again, we have to do the completing square. So I rewrite the equation into x squared plus 6x. Since my leading coefficient is a 1 already, I'm taking the linear term coefficient 6 divided by 2 and square it. When I add this number, I make sure I add it across the other side of the equal sign to maintain balance. How about the y? So I factor out the 4 and -8. Factor out 4. So I have y squared minus 2y plus, again, take the linear term coefficient divided by 2, then square it. So what am I actually adding there? Don't forget, it's inside the parentheses, so you will have to multiply it by 4 of that number. It's inside the parentheses. So -2 over 2 squared. Multiply it by 4. So we would have x squared plus 6x. 6 divided by 2, that's 3. 3 squared is 9. 4 times y squared minus 2y, -2 divided by 2, that's positive 1. -1. -1 squared is positive 1. So we would have -9 plus 9 plus 4 times 1, which is just 4. So now we can rewrite this 3 into perfect square format. X plus 3 squared plus 4 times y. So these 3 terms are being put into perfect square form. -9 plus 9 plus 4 equals 4. Divide both sides. Remember, you have to keep your constant equal to 1. So make sure you divide everything by 4. We have 4 x plus 3 over 4 plus 4 over 4, that's 1. So y minus 1 over 1 equals 1. So from here, can you identify the center location, the ABC parameters, vertex, and the foci? So let me quickly go over this once again. 4 is greater than 1, so we know our A. So A is going to be the square root of 4, which is 2. B is going to be square root of 1, which is 1. C, how about C? So in ellipse, C squared equals A squared minus B squared, which is 4 minus 1. So that is 3. So gives us the value of C equals square root of 3. The center is going to be located at -3, positive 1. The major vertices. So vertices we have from the center location -3 plus A minus A, which gives us -1, 1, -5, 1. The foci, so again, it's going to be horizontally oriented. So it's going to change the x value only. So from the center location, we add c unit, we subtract c unit, which is -3 plus square root of 3, 1. -3 minus square root of 3, 1. So if you graph equation number 4 of the ellipse, what does it look like? So on your graph, since our a is equal to 2, b equals 1, so from the center location, -3, 1, a is going to be 2. It's underneath the x, so we should have a horizontally oriented ellipse. So again, a equals 2, 2 is greater than 1, so it's underneath the x, so your ellipse is going to be horizontally oriented. Question number 5. The hyperbola equation given is 9x squared minus y squared minus 36x minus 6y plus 18 equals 0. Why do I know it's a hyperbola? So notice again, the quadratic term coefficient are different in size. So I'm looking at the quadratic term only, x squared, y squared. Their coefficient different in size. So that's the biggest clue of all them all. Next, I'm going to rewrite into standard form. So I put the x together, x squared term with the x, y squared term with the y. Factor out 9 from 9 and negative 36. So I have 9 times x squared minus 4x. How do I complete the square? Take the linear term divided by 2, then square it. Whatever I add to one side, I have to add to the other side. It's inside the parentheses, so I have to multiply. 9. For the y, I do the same thing. Take the linear term coefficient divided by 2, then square it. And again, it's inside the parentheses, so I will have to multiply by the -1. So now I have 9x squared minus 4x plus 4 minus y squared plus 6y plus 9 equals -18. So 9 times 4, I have 36 minus 6 divided by 2, that's 3. 3 squared is 9. So these three terms I can rewrite into perfect form as x minus 2 squared. These three I can write into perfect square form as y plus 3 squared. -18 plus 36 minus 9, so that's positive 9. Divide everything. Remember I said keeping your coefficient equal, the constant equal to 1. That's how you represent the hyperbola in standard form. 9 divided by 1, so basically that turns into 1. Nine divided by 1, 9, that's 1. So what's going to be our a, b, c parameter values? So 1 is greater than -9, so our a is going to be square root of 1, which is 1. B is going to be square root of 9, which is 3. And c in this case, c squared equals a squared plus b squared, which is 1 plus 9, that's 10, giving us the value of c squared. C is a square root of 10. So since 1 is underneath the x, we will have an opening left and right horizontally oriented hyperbolas with the center location located at, so our h and k is going to be located at 2, -3. The vertices is going to be located at, so again, horizontally oriented, it's going to change your x value only. So from your center location, 2 plus a, 2 minus a. So change the x coordinate only, y coordinate remains the same. The foci, again, it's horizontally oriented, so it's going to change the x coordinate only, keeping your y coordinate the same. So 2 plus root 10, comma, -3, 2 minus root 10, comma, -3. How about the asymptote? The asymptote, I'm going to explain it in the graphing part. Graphing the hyperbola. Don't forget, we're using the rectangular box method to help us identify the asymptote. So let me quickly go over the asymptote information. I marked it in color blue and red. With the center location is our center for the hyperbola, which is 2, -3. And the A was 1. So from here, I draw the box of 1 unit, left and right. From here, I have the B is 3. So from this location, I add 3, I minus 3. And here's our rectangular box. Rectangular box is by connecting the diagonals. So from A to D, B to C. So how do I write these linear equations? So passing through the center locations, as you can see, x minus 2, y minus -3. How about the slope? Rise over run. So rise is 3 units, run is 1 unit. How about the red one? Rise is -3, so it actually go down by 3, run 1 unit. So I have y minus -3 equals -3 x minus 2. So I'm using the point slope form. So rewriting them into slope-intercept form, the blue one is going to be represented as y equals 3x minus 9. The red one is going to be y equals -3x plus 3. So those are the asymptote. And to remember, we said about the hyperbola is going to be horizontally oriented because your A is underneath the x, which 1 is greater than -9. Number 6. From the given information, we can identify the circle center location at -3, 2. The radius, how about the radius? So you can count from your center location to one of the edge. So 1, 2, 3, 4, 4 units, giving us the information of radius equal to 4 units. So what's the circle equation representing this equation look like? X minus -3, so x minus h squared, plus y minus k, so k is 2 squared, equals r squared, which is 16. Number 7, you're given a parabola. The information so I can identify the vertex is going to locate it at -4, 0. The focus, so if you graph it, you'll find the focus is going to be located at -4, 2. The directrix is going to be equidistant, so that's 2 units away, y equals -2. What about the equation of the parabola? So using the information, I have x plus 4 squared equals 8y. With these given ellipse equations, we can identify the center for this ellipse is going to be located at 4, -5. And if you count the major axis, 4 units, 3 units, so it's going to be horizontally oriented. 4 is greater than 3. Followed by c squared equals a squared minus b squared, which is 16 minus 9, so that's 7, square root of 7, representing the c units. So now we can find the major vertices location is going to be from your center location at 8 units, you subtract 8 units, which is 8, -5, 0, -5, and then both sides again is changing the x coordinate only. So it's going to be 4 plus square root of 7, -5, 4 minus square root of 7, -5. The equation is represented here. Number 9. This is an hyperbola. So using the information, I can identify the center is going to be located as 3, 0. With a equal to 3, b equals 5, square root of c equals square root of a squared plus b squared, which is 34. Vertices is going to locate it at 3, 3, 3, -3. Both side is going to locate it at 3, square root of 34, 3, negative square root of 34. How about the asymptote? So the asymptote information is going to be, so remember we are passing through the point of 3, 0. So it's going to be y minus 0 equals, the slope is going to be 3 over 5 x times x minus 3. And the slope, the other one, the negative one, is going to be y minus 0 equals -3 over 5 times x minus 3.